we left off yesterday. So we're talking about derivatives, and what we know so far is that the derivative is the slope of the tangent line. We know that when we looked at those slopes, they were an instantaneous rate of change. So we could also say that the derivative, or f prime, is an instantaneous rate of change. We will spend some time interpreting what a derivative means. So we'll have these questions pop up periodically. And I'm probably going to throw them at you a lot until I'm really confident that you're answering it the way I want to answer it. If I'm asking you about the meaning of a derivative is telling you how things are changing at a particular point in time. So this says a manufacturer produces bolts of a fabric with a fixed width. The cost of producing X yards is C equals F of X dollars. So C is our cost. What is the meaning of the derivative? So a derivative is a rate of change, right? And we are doing, when we calculated those derivatives yesterday, we were doing the slope of a tangent line. So slope is y over x, or change y2 minus y1 over x2 minus x1. Change in y divided by the change in x. What is y in this case?
C.
Y is our C, so that's dollars. What is x?
F of X.
X is the yards.
Yeah.
So when I say what is the meaning of the derivative, I am saying we know a derivative is a rate of change. So it is the rate of change in production in terms of yards produced. The rate of change is telling me how my production is changing. What's happening at any particular X value. When I asked for the units, we said, well, it's a slope, change in Y over change in X. So my units, this would be dollars. A division is like a per yard.
So this is basically explaining slope.
Yep. So you, back in Mrs. Keller's class, you had to write out what slope was. And, sometimes write a sentence to put a label on it. That's all we're doing here. I want you to understand, though, anytime I'm asking about a derivative, it is a rate of change. Okay, it does not tell me what the cost is at a particular point. If I get a derivative of 3, it doesn't mean it costs $3. It tells me the cost is changing by $3, or the cost is increasing by $3. So in practical terms, what does it mean to say f prime of 1,000 equals 9? So the 1,000 is my x, and we've already said x is yards. The y we said was dollars. Okay, this does not mean it costs $9 to make 1,000 yards of fabric.
That's what I was going to say.
Because this is f prime. The derivative is how the cost is changing. So it tells me when I make 1,000 yards of fabric, my cost is increasing by $9. So I don't know what it cost me to make 99 yards of fabric, or 999 yards of fabric, but to make that 1,000th, I would add $9 to my cost. If I wanted to make another yard, I would assume it would go up by about $9 again. So this tells me how the cost is changing at a particular point. So if we want to write out a sentence what this means. 1,000 yards of fabric are produced cost is increasing, $9 per yard. So it doesn't tell me what the cost is, just how the cost is changing. So next question. Which do you think is greater? F prime of 50 or F prime of 500? We don't really know. I didn't give you an equation, so we can't like mathematically prove it. But let's just think about it. So when you produce something, if you're making something, okay, you have some certain things that you have to pay for no matter what. If I'm going to produce fabric, I'm going to have some equipment, right? And I have to buy that equipment no matter how much fabric I'm producing. And then for every yard of fabric, I also have to buy the supplies that go with it. So the supplies, the more fabric you make, the more supplies you need. Your equipment, you need the same equipment no matter what. So what happens if I go from producing 50 to 500? What's going to happen to like my cost per yard?
It's gonna increase.
The cost will increase. What about per yard though? Let's think about this in a different scenario. Okay, let's say you want to start selling cupcakes, right? But your mom said you can't use her oven because she needs it, so you have to buy your own oven to put in the house to make your cupcakes, okay? And so let's say you go out and you buy an oven for $750. And then let's say it costs you, I don't know, $10 in supplies to make a dozen cupcakes. So if you produce 1 dozen cupcakes, how much money have you really spent to make that 1 dozen cupcakes? $760. Okay, that was not very profitable. Let's say if I produce, let me write that up. So if we make 1 dozen, my total cost is $760. Good luck. So that means my cost per cupcake was $760 divided by 12. Grab a calculator if you need to.
I got you guys.
Can I grab my phone for them?
63.3 repeating.
Okay. So if that's all we make, it costs you, in actuality, over $63 for every cupcake you make. Okay, but let's say we end up selling 100 dozen. All right, so what would my total cost be in that case?
870.
10 times 100 is 1,000.
Oh, I'm just kidding. Why did I take 12 times?
So my cost per cupcake, so 100 dozen, that's 1,200 cupcakes. So if you take your $17.50 and divide by your 1,200 cupcakes, it only costs me $1.46 per cupcake that time. What's the difference?
You made more cupcakes.
I make more cupcakes. You
Mass
have
production.
some things that you have to pay for no matter what. But the more you make, the more things you can divide that cost over. Okay? So in general, which do you think is going to be bigger? The rate of change tells you how much my cost goes up. If I am producing only 1 dozen cupcakes, If I'm gonna make one more cupcake, I'm gonna have to spend another $63. But if I'm making 100 dozen cupcakes, when I add one more cupcake, it's only gonna cost me another $1.50. So which one would be a greater rate of change? F prime of 50 or F prime of 500?
500. What? You're making 500 cupcakes.
Right. So we're comparing not the cost, how the cost is changing. Remember, when we're only making a few, the cost to make one more is really big. When you're making a lot, to make one more, it's just a small increase. So F prime of 50.
Oh, okay. I misunderstood the question, I think.
Okay. This makes sense now?
Yeah, because it's better, this is saying it's better off to do the F of 500.
Right, because your cost per item is
It's
lower.
smaller.
Okay, what about 5,000? Can you go home tonight and produce 5,000 cupcakes?
Probably not.
Probably not. So if I place an order for 5,000 cupcakes, what are you going to have to go home and do?
Do a little bit at a time.
Yeah, or get another oven, hire some friends to come start cooking for you. You're going to have to add more equipment, right? So what happened to your costs? Are you still only spending $1.46 for every cupcake? No, we had to upgrade all of our stuff, so now we're back to spending a lot of money to make that. So at some point, you can't just keep adding stuff forever. We can't say it's always cheaper to make more. At some point, you reach your maximum capacity, and to make more, you're going to have to upgrade everything. So we have to be careful. There is a point where it's no longer going to be profitable. So I'm going to write out F prime of 5,000 may be more costly. If production becomes inefficient. Okay. People probably aren't going to want you to say, well, I'll bring you 5 dozen cupcakes every day until I get to the 5,000. They probably don't want a few at a time. They want them all at once. So if I have to go home and produce that all at once, that's going to cost me a lot of money because it is not going to be efficient. All right. Questions there? So let's take a look at kind of comparing derivatives again, but this time I'm giving you a graph. So here's my graph. I want to arrange these in increasing order, so small to large. So we have 5 things. Okay, let's see. This one's just a 0, so that's fine. G prime of -2. What does that mean? In terms of a graph, what's the derivative?
Rate of change.
It's a rate of change.
Slope.
Slope of a,
Line.
what kind of line?
Prime.
Tangent line. So this is saying the tangent line at -2. So here's -2. So I'm talking about the slope of this tangent line. G prime of 0. So that would be the slope of this tangent line. G prime of +2 would be the slope of this tangent line. G prime of 4. All right, if I'm looking at these, one of these lines stands out to me as being different than all the rest. What's true about G prime of 0?
It's negative.
It's a negative. This would be a negative slope. So that's going to be my smallest. And then after a negative, we would use 0. And then we have to have all of our positive numbers. Okay, so we're putting them in increasing order. So the smallest one would be the flattest line, the smallest slope. So which of these would have the smallest slope out of those 3? 4. That's the flattest line. Okay, the others, it's a little bit hard to tell at 2 and -2. So if I'm looking at these, can you tell which one is the steepest? It's kind of a toss-up. I would probably accept it either way if you put, because it's really without having some more information to get exact slopes. They are very close to each other. So I may put G prime of 2 and then G prime of -2. But these, I would allow you to switch because it's just hard to tell from our graph. But we could for sure say G prime of 0 is the smallest because it has a negative slope. Then you would have 0. G prime of 4, that's definitely the less steep of the lines. So that would come next. Okay. Let's go ahead and do...
My allergies about to kill me.
It's just allergies? You really sound...
No, like I literally am fine. It's just my allergies.
That's miserable.
Because after I run, my allergies are so bad. Like, I was fine until after I got done running yesterday. And then it happens every single day. It'll be done by tomorrow.
Well, the flowers in here may not be helping your allergies either.
Oh, I think it's fine.
Okay.
Did you get a little flowers from your boob?
No, it's from a friend.
Oh.
Just 'cause had a bad week, day, I don't know.
Aw.
But just a nice song. Okay, let's take a look at this one. So if a rock is thrown upward from the planet Mars with a velocity of 10 meters per second, its height after 2 seconds is given by this equation. All right, so we've got an equation. You need to throw something in real quick. I'm gonna make it for him.
He's not gonna make it.
How do I find the velocity after 1 second? I have a height function. How do you get from height to velocity? Velocity at 1 second. That's like an instantaneous velocity. And we can make a chart.
Or we have that formula.
But now we know that that's really just the limit, so we could do the derivative. And yesterday I showed you 2 different options. You know, one was the limit as x approached a, and one was the limit as h approached 0.
Let's do H0.
Okay, I like it. So we are going to do the limit as h approaches 0. So remember from yesterday, that was f of x plus h. What's my x here?
1.
Okay, so f of x plus h, that means you're going to this equation, you're replacing your t with 1 plus h. Minus f of x. Hey, can I make a suggestion? Part B has us doing this when t equals a. Can we do part B first? Because it'll save us a ton of time.
Sure.
Okay, so in part B, we're just not using 1. We're going to keep it as a. So it's saying a plus h. Minus f of a. All over h. And again, the only reason I did that is I looked ahead to the next part and realized I have to do both, so this would be the easier one to do first. All right, now we have to do algebra. So if we distribute, we get 10a plus 10h how much can I do at once? What's a plus h squared?
A squared plus 2a plus h squared.
And I need to distribute a negative 1.86 through that. So negative 1.86 a squared minus 3.72 ah minus 1.86 h squared. Okay, minus 10a plus 1.86 a squared all over h. So now what?
Cancel out your 10A's and your 1.86A squared.
Everything that's left could be divided by
H.
h. So I'm going to take an h out of everything that's left. So then if I plug in a 0 for my h, what do we get?
A number, but I'm just not there yet. Let's try this.
So if h is 0, that term goes away. So we just get 10
Next equation.
minus 3.72a.
Wait,
Here's the reason I have to do part B first. So now in part A, we could have done this whole thing at 1 second, but now we have a formula. So now if I said after 1 second, all you have to do is plug in the 1. So we get 6.28 meters per second.
oh my goodness gracious.
What's wrong?
I just didn't. I just did multiply half this stuff.
Part C, when will the rock hit the surface? Okay, so if the rock hits the surface, what's the height? 0. Remember, the original equation I gave you was the height equation. So all you have to do is set that original one equal to 0. And you could factor a t out. So if we set each part to 0, divide, and get t equals 0 and 5.38. Which one would be when it hits the ground? What's the first one at time 0 representing? Yeah, it started on the ground, we threw it up, and took 5.38 seconds to come back down. So then part D, with what velocity does it hit the surface? We found a velocity formula. That's the derivative. This gives me a shortcut for finding velocity. So I can just do this formula and plug in 5.38 for my t, or for my a. If you round, you get negative 10.01 meters per second. Why would it be a negative velocity?
Because it's falling.
Yeah, it's coming down. Velocity is just speed with direction. Positive means you're going up, negative means you're coming down.
Wait, where did 10 minus 3.72 come from?
The formula we found when we did our derivative. The very first thing we did.
Okay. And then, okay.
Hello.
Could I send Ambrose to come see how you want that set up, or you just wanted to set up any certain ways? I know you got to have a.
Right, I'm trying to decide, because we used to put the podium in the front, or we put it along the side, and then we made like an aisle in front of it and put chairs on both sides. But if we don't have enough chairs, I don't know how I'm gonna, what do you think? I've got some kids that like their 8-hour classes online, so they volunteered to come help too, but I don't know.
If you have enough chairs. Let me check with them and see.
Okay, and maybe if we just had enough for the members, I could just have a membership there and let the families
Sit in the, at the tables. Yeah.
And we could do that.
Okay.
So I have 38 members, some of them will sit the officers at the very front, of the table at the podium.
Okay.
And we'll put risers in the corner, which Mr. Long has any risers, but I don't know where they're at.
Okay. I just want to try to get a hold of Amber before he leaves
Okay.
today. So
Okay.
think about
And
it.
I'll try to have, because, but maybe that would just be easy. So if we put the podium where we usually do, set a table up for the officers, risers in the corner, and then maybe we just set out some rows of chairs for the members. So just if we pick up a few tables instead of
Like, it
all
just
of them.
feels like we're just doing this
And then we,
Have tables. Kind
Mhm.
of. I guess straight, but it's kind of moving backwards
yeah.
and give enough space for the chairs. Okay. Well, I'm probably gonna have him run to you. I got a meeting, so I'm gonna have him check in with you.
Okay,
Kind of get an idea.
all right, thank you.
Sure.
Why don't we stop here for today? We'll do the last few examples tomorrow and give you a little time to work on homework, but you have to be working